Now let's go over another solution that will introduce other programming concepts. Let's go to the easy section, and we are going to go to program go the distance. The goal here is to shift this set of red blocks over one to the right, and have the pile be in this location. And we're going to leave all of the other yellow blocks in their place. So how can we achieve that? We can go over to the right 1, 2, 3, 4, 5, 6, 7 times, right? And then start moving this stack over. So why don't we do that now? Let's move this over 1, 2, 3, 4, 5, 6, 7. Oops, I have only one register left. So I can only fit one more instruction in this program. So what I'm going to do is use program 2 to finish this. So I'm going to put a call to program 2. And I haven't created program 2 yet, but let's think about what program 2 will do. Well, program 2 will just start moving this whole stack, we'll move this whole stack over by 1. Now how do we achieve that? When we're at this location, in order to move the blocks, we go down, we grab a block, we move it over, and we place it back down, and we go to the right, and then we want to repeat that process, right? So if we want to repeat it, how do we get that to happen? Remember, we use a call to the beginning of that same, procedure. So by placing a call to program 2, we go ahead and start at the beginning of that procedure and execute the instructions again. And remember, this is an infinite loop. But once we've stacked all the blocks, we've successfully achieved our goal, so it will stop. So I would expect this program to run. I haven't actually tested anything. I've just used logic to think about what's going to take place in each one, knowing the execution flow, knowing that we'll start at program 1, we'll follow this instruction, and then this one, this one, this one, this one, this one, this one, and this one will make us jump over to here. Then we will execute this, which will make us go back here and do these over and over and over again, right? So let's go ahead and test that and see if that works. And I'm going to fast forward. Yes, we got the solution. But wait, we only earned 1 star. What does that mean? Well, if you go to the hints, you are instructed on how to solve this problem in a way that will give you a 3-star solution. And then you're told that the shortest solution is using only 4 registers. Well, we've certainly used more than that. We actually haven't done this so inefficiently in terms of the number of instructions to execute. We've done this inefficiently in terms of the number of registers being used. And we will see what I mean by that in just a moment, okay? So let's go back and figure out how we can use less registers to achieve the same goal. And in doing so, we're going to find that we actually end up executing more instructions. So we end up having a solution that is less efficient in terms of the number of instructions to execute, but we use less registers to achieve our goal, right? And we just end up repeating instructions over and over again. So what can we do? Well, we know we need this set to begin with. But hey, didn't they say that the shortest solution was using only 4 registers? That means I have to stick to program 1, probably, right? So let's clear this, and let's start over again. Now, what are the basic things that I need to do? I need to move over to the right, and what else do we need to do? Well, in the case that we're here, where we have the box stack, let's say we have our claw there, then we need to grab a block, and then we need to move it over back, to the left, and we need to drop it right? And then we need to repeat that pattern. So I'm going to put program 1 to repeat it. That gives us a start. We have a much shorter potential solution. And now let's step through the solution slowly so we can see whether or not it works. Okay. We're going to move over to the right. We're going to go down. We're going to grab a block. Then, oops, we went back. We don't want to do that, do we? We only want to go back if we have a red block. And right now we have a yellow block. So how about we restrict this instruction to be executed only if we have a red block in our claw. So I'm going to stop that, and I'm going to say if we have a red block, oops, here we go, come on, there we go. If, when you went down and grabbed a block, it's red, then go ahead and shift over to the left. Otherwise, we're going to go down. Let's see what happens. Let's trace it. So, right, grab the yellow, skip the red, and we put it down. Okay, well, that's good, actually, right? Because we didn't want to move the yellow. Now what is going to happen? Notice that our instruction here, the last instruction was down. The next instruction is go back to program 1, to the beginning of this procedure, and execute. Now we're back to program 1, and guess what? We went over to the right. Let's see if that continues to happen. Well, we're moving right along. Now notice, we have a lot less instructions in our registers, that is, but we're actually executing more instructions. We're doing more steps. We are grabbing a block, and we are putting it back down, and then shifting over to the right, grabbing a block, putting it back down, and shifting over to the right. That's executing more instructions in the end if you were to count them and total each one that gets executed. That's less efficient than before in terms of the number of instructions that are executed. But there are less instructions in our register, so the program is smaller, but the execution time is longer. All right, let's keep going and see if we end up getting the red blocks in the place we want them. Oh wait, it worked. What happened there? We went down and tried to grab a block, and then we found that it wasn't red, right? So we went back down. We didn't have a block to put down. We just ended up pretending like we were going to grab something, but again didn't grab anything. Then went back to the start that said, oh, go to the right. So we went to the right. Now we went back down and we grabbed a block. Good. Guess what? This one's red. So the next instruction is this, right? See how this is the highlighted one? The next one to execute will be this one. And it will move to the left. The claw will move to the left if you have a red block, which we do. So there we go. We moved over. And now we're going to put it down. Now what's next? We're going to go back to the beginning of program 1. And we're going to continue grabbing blocks. Yay! We earned 3 stars. Great. But remember, they said the best solution was using only 4 registers. And we're using 1, 2, 3, 4, 5. So why don't we take some time to get the best solution? What can we do to get our solution down by 1 register? Well, let's take a look at what we have here. We have 1 instruction for moving over to the right, 1 to move down, 1 to move left, and then another 1 to go down, and then program 1. Well, the only instruction that is repeated in this process is the down. Right? So I'm going to guess that I have to eliminate 1 of those in order to get the shortest solution using only 4 registers. Now we need to determine which one of those to eliminate. So we want to move right. And if we have a red block, then we want to move left. But how do we get a red block? Well, we had to go down. If we eliminate this one, we never go down, so we're going to be in trouble, right? We will eventually do it if we have, when we skip over that, and then we'll go down there. But I think that we're safer moving to the right than going down and then coming back left if we have a red block. So let's try removing this instruction and see if that works. I'm going to just press play and let it go quickly through. Oops, we have a problem. Now it's time to debug our program, okay? So what does that mean? That means we're going to step through the execution process and we're going to observe where we went wrong and then see if we can fix them. So let's debug by stepping. We're going to start over again. We're going to go to the right. Then we went down and got a block. It's not red, so we're going to skip the next instruction. We're going to go to program 1 and start at the beginning, right? Which is going to say move to the right. And sure enough, we moved to the right, and then we went down. Did we want to do this? No. We didn't want to move to the right if we had a block, right? Because even if we had a red block, we never want to move to the right with a red block. So, what if we put a conditional statement on this, right here, on the right arrow? We say we only move to the right if we have nothing, no blocks in our claw, okay? So I'm going to associate none with this instruction. So this reads, if you have no blocks in your claw, then move to the right. Then we're going to go down regardless of whether we have something or not. And we're going to go back to the left only if we have a red block. And then we're going to go back to the beginning and repeat this process. So I'm just going to press play and let it go. Wow, that worked. And there you have it. We have our best solution, the 4-register solution. Let's trace it and just review why this works. It has nothing in the claw, so it moves over to the right. Then it goes down. It picked up a block, but it's not red. So it's going to go to program 1, right, which starts at the beginning. But the first instruction said, go to the right only if there is none in the claw, and there's a yellow block in the claw. So instead of executing that, it skips it and went to this one, which said, put it back down. Put it back down, and because it has no red box in its claw, it won't execute that. It'll go back to program 1. Then it will come to this instruction and say, oh yeah, it's got none. There's no blocks in my claw, so I can move right. And there you go. And then we're going to go ahead and go down and grab a box. Notice because it's yellow, it's going to go to the beginning of program 1 and continue to do that. So that is how we achieved this goal. Again, this cargo bot game will reward you for using the least amount of registers, which translates to it rewards you for using the smallest set of instructions to solve the problem. So even though a solution might be less efficient, like you do more steps, you do execute more instructions to achieve your goal, it will like that you used a smaller set of instructions, okay? So you might do more work, but it's a prettier little program. Right? And the best way to make your program as small as possible is by finding patterns and using these procedures, okay, to put those patterns in and calling those procedures maybe to repeat over and over again. And then eliminating any redundant calls that you see, things that you see you happen to do more than one time. Well, maybe you can get rid of one of those and reuse the instructions that you had and rearrange things a little bit. So many of these games, these problems are going to require a clever little use of your conditional statements here and good use of your procedures, your labeled program 1, program 2, program 3, and program 4. Okay? Great. I hope you've enjoyed this little demo and that you go and play this game. It's a wonderful game.